Hey there, everybody. This is Mr. Dickin here with yet another video lesson for you. Today we're going to talk about a different type of polynomial division called synthetic division. Synthetic division is something that is an alternative to long division, and most people tend to have a strong distaste for polynomial long division. A lot of time takes a lot of space. Synthetic division only works if our divisor is a linear factor. So what that means is our divisor has to be like an x plus 3, or maybe, an x minus 2 or something like that. It has to be a linear factor. Looks like I'm having some autofocus issues. Hold on 1 second. Let's see here. All right, that ought to do it. Linear meaning there's no crazy exponents happening on these x's. So if I saw something where we're trying to divide by like an x squared minus 1, well, that's not going to work. That's not a linear factor. All right, so first thing we need to do is set the divisor equal to 0, then solve. That number gets put into the quote-unquote start box. You don't know what the start box is yet, but if we had a divisor factor of an x plus 3, the 0 associated with that would be a negative 3. So in our start box, we might have a negative 3. Over here, if we had an x minus 2, the 0 associated with that would be a 2. So in our start box, we'd put a 2. Next, you're going to write the coefficients of the dividend next to the quote-unquote start box. Now, the dividend is whatever we are dividing into. So I'm making up a polynomial here. Let's say if we had 3x squared plus 1x minus 2. The coefficients are 3, 1, and negative 2. So we'd have a start box followed by the numbers 3, 1, negative 2 when we do our division. Next, we're going to write the very first term below the line. And again, once we get into an example, this will make sense. And then we're going to follow the process of multiply, then add. And I'm going to even throw in, we always go down, diagonal, down, diagonal. And again, that will make sense in just a second. We always add down, and you always multiply diagonal. That's a little dot, not a minus sign. So you add down, you multiply diagonal. The final value, whatever you're left with, is the remainder. In a perfect world, we like to see the remainder equal 0. We like to see that. It doesn't always happen, but we prefer to see the remainder equal 0 because if we do, we have a root of the function. So if you haven't yet, if you want to pause the screen to jot some of this down so the next example doesn't make, or makes a little bit of sense, you might want to do that. So let's take a look. All right, so here we're trying to divide x squared plus 3x plus 5 divided by x plus 1. Well, the 0 associated with an x plus 1 would be an x equals negative 1. My coefficients here would be a 1, a 3, and a 5. So I'm going to start off by writing my negative 1 came from this guy into the start box. And then here I just have the coefficients listed. Now, when I do this, I always start off by taking the first value and kicking it straight down. So I'll put a 1 down here. And then we have to go down, diagonal, down, diagonal. Every time I go diagonally, I'm always going to multiply by whatever this number here is. So in this case, every diagonal move is getting multiplied by negative 1. So I have a 1, and then to go diagonally, I multiply by negative 1, which gives me negative 1 here. Then I add straight down. 3 and negative 1 gives me a 2. Then I go diagonally, so I multiply. When I go diagonally, when I multiply here, I'm multiplying by negative 1, so this gives me a negative 2. When I add straight down, I get a 3. This is the last number. This is the remainder. So for this, if I started with an x squared and I divided away an x, my final answer, the highest degree, should be a plain old x. These are going to tell me the coefficients here. So I have a 1x plus, because this was positive 2, and then my remainder here was 3, and I put it over my divisor. I don't know why I wrote x plus 2. That should be an x plus 1. So this is the final answer. 1x, you don't need to write the 1 if you don't want to, x plus 2 plus the remainder of 3 over x plus 2. That's a heck of a lot quicker than doing polynomial long division. Let's try another one here. X to the fourth minus 10x squared plus 2x plus 3 divided by x minus 3. You'll notice we've skipped the x to the third term. We went x to the fourth straight down to x squared. Well, anytime that happens, we have to fill in the blank with a 0. So we have to make sure we're filling in the blank with a 0. From here, I'd steal the coefficient. So I have 1, x to the fourth, 0, x to the third, negative 10x, positive 2, or sorry, negative x squared, positive 2x, and a positive 3 is my constant. If I'm dividing by in x minus 3, then I'm going to use a positive 3 as my starting value. So let's go through the process. Again, we go down, diagonal, down, diagonal, down, diagonal. And I like to write out these arrows. By no means do you guys have to. We start off by dropping the first number down. So that's a 1. Every time I go diagonally, I multiply by this number. So 1 times 3 is 3. We add straight down. This gives me 3. I go diagonally, I multiply by 3. That's going to give me a 9. I add straight down, I get negative 1. When I go diagonally, I multiply by 3. So this gives me a negative 3. When I add straight down, I get a negative 1. Multiply diagonally, I multiply by 3. So negative 1 times 3 is a negative 3. Add straight down, and I get a 0. That last number is my remainder. Now remember, we like to have remainders of 0, and we'll get into that later. But we prefer to have 0 remainders here. If this problem started off with x to the fourth, and I did synthetic division of a linear term away, so I started with x to the fourth and I divided one of the x's, then down here we're going to start off with x to the third. So it's going to go x to the third, x squared, x constant. And these are my coefficients. I have 1x to the third plus 3x squared minus 1x minus 1. And the remainder was 0, so I don't need to write it. So now we've divided that out. And again, with polynomial long division, this might have taken a heck of a lot of time. All right, last one before we jump into the next topic here. I'm going to say that you guys should probably pause the screen here. I'll do the work, and then if you guys want to come back, check, and maybe see how you did there. So right here, I see that we're skipping an x to the fourth, so that's where the 0 comes from, because what's the x to the fourth term, and there's no other skip term. It tells me I need a negative over here. So when we start our process, we drop the first term down. That'd be a 3, and when I go diagonally, I'm multiplying by a negative 2 each time. 3 times negative 2 is a negative 6. Go straight down, we add. Times negative 2 is 12. Add straight down, I get 4. Times negative 2 is a negative 8. Add straight down, I get a negative 6. Times negative 2 is a positive 12. Add straight down, I get 11. Multiply by a negative 2, I get negative 22. Add straight down, I get negative 21. That's my remainder. I started off with an x to the fifth. I divided out one of the x's. That means my final answer should start off with an x to the fourth and then work its way down. So I've got 3x to the fourth minus 6x to the third plus 4x squared minus 6x plus 11 minus 21 over my divisor of x plus 2. And then we are done. Yay. All right, so now let's get into the remainder theorem. The remainder theorem states that you can actually use synthetic division as an alternative to plugging in an x value to a function to evaluate a function. So here we have an example function where f of x equals 3x cubed plus 8x squared plus 5x minus 7. If we wanted to do f of negative 2 the quote-unquote old way, we would just plug in negative 2 anytime we see an x and evaluate from there. Typically, most of you would do this straight in your calculator. But if you do that, you run the risk of maybe forgetting parentheses and getting sloppy with that. Conversely, these problems might show up on a non-calculated portion of the quiz test, so you got to make sure we know how to do it by hand. So if I do synthetic division and take whatever the input value is, I don't need to mess around with flipping the signs or anything. If I want to find f of negative 2, I can just do synthetic division with negative 2 on the outside, and we run through our process here of down diagonal. And as I do that, what we're going to see is the remainder that we get is the exact same as the function value we would have gotten should we plug in our value. So this, I would argue, is a much faster way to get a polynomial function value by hand as opposed to plugging things in. Less room for error over here. Okay, less room for error. So here is the formal mathy definition here. If we divide by a factor or a divisor, then the remainder is the same as that function value at that input. This is another reason why we prefer to see the remainders of 0, because if I see a remainder of 0, that means my divisor term divides nicely out of it, which means it's a factor, which means it's a root or an x-intercept of the function. So if we want to use the remainder theorem here, find f of 2 of this function and f of 3 of this function, I could plug things in the old school way. That's definitely an option. But I'm going to assume my calculator is broken and I can't do that. So I have to use the synthetic division remainder theorem in order to get these. So you'll notice I've stolen the coefficients, 2, 4, negative 10, negative 9. There was no skipped term, so I don't have to worry about that. And we can just go through our synthetic division problem. We always start by dropping down that first term. We go down, then diagonally, we're multiplying by this number here. Then we add straight down, multiply by negative 2, add straight down, multiply by negative 2. I get a positive 20, add straight down, we get an 11. So that's my remainder. F of negative 2 equals 11. I can do the same thing for f of 3. Again, we've got our coefficients. We drop the first number straight down, I get a 2. Anytime I go diagonally, I multiply by this number here, which is a 3. So this would be a 6. Drop down, I get a 10. 3 times 10 is 30. Add those, we get 20. 3 times 20 is a 60. Negative 9 and 60 is a 51. So f of 3 equals 51. And if I'm going to be entirely honest with you, I probably wouldn't want to try doing that method mentally without a calculator if I'm plugging in a number like 3. Because this would be 2 times 27 plus 4 times 9 minus 10 times 3. That would just be a lot of numbers to kind of keep track of. So this is a phenomenal alternative to doing that. All right, as always, you guys know the drill. If you have any questions, do not hesitate to let me know.